Hello guys, welcome back to our channel again. Today we will solve the 27th question of June leetcode challenge. So the question is, we have given an integer and we have to represent it into a number which is a perfect square, and we have to count it how many such number we require to make a perfect square, or how many perfect square numbers we require to make that number. So if we take the example of 12, how we can make 12? We can make it by 4 plus 4 plus 4, so this will be 12. Now we use these three integers or three numbers, so the output will be 3. In the case of 13, we'll use 4 and 9 only. Now if I have to do it for, suppose I have to do it for 16. Now how can I represent 16? I can represent it only by 16 only. So I required one number only. Now in case suppose it is 28. Now how many integers we require? We require 4 integers. So in the case of 24 we require 4 integers, whereas in case of 12 we require 3 integers. In case of 13 we require 2 integers, whereas in case of 16 we required only 1 integer. Now how we can represent this 28? We can represent it by, so we can represent 28 by this 4, 16, 4, 4, 4, 4. So we require to represent 28 into these 4 integers: 16, 4, 4 and 4. So we know that what we have to do, we have given an integer, we have to represent it into perfect square numbers, and we require that how many perfect square numbers we require to represent this current n. Now for understanding the question, we will discuss two approaches. First is dynamic programming approach. Now we all know that if we have to count something in some or another way, dynamic programming comes in between. So in this also we have to count the number of numbers, so our dynamic programming will be used. A simple logic that if we have to count something, dynamic programming will come in between in any way. So in this also dynamic programming is used. Now how we will use dynamic programming and why dynamic programming is used. So first question is, why dynamic programming we are using. So we all know that what all benefits are there of dynamic programming. First benefit is there that every time we does not require to traverse each and every node and all these things. But in this, how we will use is a big question. So suppose we have to calculate for 12. Now we all know for DP we will start calculating from 0, then 1, then 2, then 3, till 12 we will calculate. So first of all, verbally we will check that, or verbally or by writing we will check that how we will do it for 12. Now what we will do, first of all we will create a DP array. Now initially I have created a DP array of size n, so it is of size 12. Now what initially I will do, I will initialize its zeros index, means it is of size 0, so I'll initialize its 0th index by 0. Now what this 0 says is, for making 0 we require 0 elements, so 0 numbers. Now we will initialize first 1 also. If you does not want to initialize, leave it, we will initialize it after some time, but in my case I am initializing 1. So what this 1 represent, this 1 represent that to make 1 we require 1 digit only. Now we will discuss for all other digits. Now if we require to make 2, now what we will do, first of all we will check that by incrementing this we can make this or not. So by incrementing this 1 we can make, so we require 2 numbers to make 2. 1 is 1, so for making 2 what we will require, we will require 1 and 1. Now for making 3 what we require, so for making 3, first approach which comes in our mind is using 3 ones. So this approach only we will use, that we will use 3 ones, so we will get this 3. Now 4 comes, so what we will do, first of all initially by using 1 we can make, so we will use 4 ones. Which one? 4. 4 can be represented as 1 plus 1 plus 1 plus 1. Now don't get confused that I am using 1 because 1 squared is also 1. So don't confuse in that part that I am using 1 but we can only use the squares. So in this I can represent it by 1. Now I will check that it is using only ones. Now I will check for 2. That 2 is square I can use it for not. So I will use 2 is square. So in this case I can use 2 is square. So this can be completed in one move only. Now I look for 5. So 5, first approach which comes in our mind is 4 plus 1, so 2. Now we will check it for 2. Now first, till now what we are doing 2 multiplied by 2 plus 1. Now we have this one only, so we can't represent it into 2 into 2 because its number is 8, so we can't do this thing also. So this will also use 2. Now the only method by which we can convert this into 1 is 3 into 3, but this is also larger than 5, so we will not use this. Now we will check for 6. Now for 6, first again method which comes in our mind is 5 plus 1, but this is applicable here or not, we will check this thing. So 5 we make from 2 into 2 plus 1. Now we have 2 ones, but we can't convert 2 ones also, so we will make it 3 only. Now after that what we will check? We will check for 7. Now 7 we can simply represent it by 6 plus 1. So initially I will initialize it with 4. Now I will check that 4 or less numbers can be there by this or not. So first I will check that by one number I can use it or not. So first is 3 into 3. It is 9, so it is I will not use it. So 2 into 2 we will use 2 multiplied by 2. After that I can use 2 multiplied by 2, but it is 8 because 4 plus 4 is 8, so it is higher, so I can't use 2 into 2 also, so I'll use 1 only. So 1 plus 1 plus 1, so we require 4 numbers for 7. Now we will try to find it for 8. So initially which comes in our mind is 7 plus 1, which is 8, so we'll use this 5. Now which comes in our mind is this 7 into 1. So sorry 7 plus 1. Now we have represented 7 by 2 into 2 plus 1 plus 1 plus 1 plus 1. So we use plus for 1. So first of all we will try to make it from 1 only. So how we will make it from 1? We can make it by 3 into 3, but it is 9, so we will not use this. So first we know that we have to use this. Now by replacing these 4s we can make it 2 into 2. So now it is using 2 numbers only, so we will make it 2. Now after this 9 comes. Similarly we will do for 9 also. 2 methods. We can first it by 8 plus 1, 9. Then we know that we will check for 1, so it will be 3 into 3. So how many methods it require, or sorry, how many numbers it require? 1. So we have done it for till 9. Similarly we will do till 12. So for 10 we require 2 numbers. For 11 we require 3 numbers. For 12 we again require 3 numbers. Now we will look for the solution approach or the code which we will use in this DP solution. So we will use this code. Now first of all what I am doing, I am initializing DP. Then after this I am initializing DP0 index. Now what here I am doing, the main part. I have iterated over all the values of DP and produced each and every day in digit. So at the starting we will take n equals to 12 and then we will try to solve. So first of all, what all I have initialized? I have initialized n. First of all, I have initialized dp with 13. So with 13 zeros, initially we will initialize with 13. So initially we will use this 13 zeros. Now after that, dp 0 index is 0. So initially it will be some garbage value, but I am taking it as 0. Now after that, I'll iterate from I equals to 1 to n. So initially I will be equals to 1. Now I'll initialize dp's I index with some max value. Suppose in this case I'll taking 1000 only. Now after that, what I'll do, I'll iterate over all the values in which the square exists of j into j. Means what I'm trying to say is I'm iterating all the perfect square digits from 0 to I. So in this case we have only one value, 1. So we'll iterate over this 1 only. Now we'll take j equals to 1. Now we'll check that dp's I index, means this dp is 2 index. This dp is 2 index. We can check this, that minimum is this 1000 or dp's I minus jj, means I minus 1, means this 1, this 0 plus 1, so it becomes 1. So we'll check the minimum. So minimum is 1, so we'll assign that value here. Now we'll check the next condition for j equals to 2. Now 2 into 2 is 4. 4 is not less than or equals to 1 or I. So we will not execute now. So now I becomes 2. This will be again 100. Now j first 1. Now again we will check the same condition. It will be 1000 comma sorry. So it will be 1000 comma 1 plus 1. So it will be 2. So 2 comma 1000. Sorry, 2 comma 1000. So 2 comma 1000. 2 is minimum. So we will initialize it with 2. Now after that, 2 comes. Now 2 into 2 4. 4 is again greater than I. So we will not execute. Now we will run for 3. Here 1 again. Now here the value will become 3. Now this will be again initialized with 3. After that, what we will do, we will iterate over this 4. Now 4 comes, the understanding part comes. Now I is initially 1. Now here it comes 4 because 3 plus 1 4. So this will be initialized with initially 4. Now again loop comes, so it will be 4. I will be 2, sorry, j will be 2, but j into j equals to 4. So the condition is equal. So we'll iterate. Now this first is 4. Now we'll check this 4. So I is equals to 4. 4 minus 4, 0th index. So 0th index is 0. Here 0. Now 0 plus 1, 1. So we'll initialize it with 1. Now we will check for j equals to 3. Now condition becomes false because 9 is less than, so 9 is greater than 4. After that we'll iterate for 5 and then for 6 and then all. So similarly this condition or this dp is becoming the similar only. Now this dp is becoming similar. In example which we have verbally solved, we have got this only 1 2 3 1 0 0. Now you must see that we are using two loops in dp, so its time complexity will be high. So now if I submit the solution, I got correct answer or accepted. Now if I see more details or every detail, now its time complexity is correct or it is faster but not that much. It is less than 16% of the CPP solutions, and usage is also 86%. Memory usage is also very high. So we will reduce these both and we will try to make it up to 90 or more than 90%. So now we'll look at our second approach. So first of all, what we have to do, we have to return only 4 numbers. It can be 1, it can be 2, it can be 3, it can be 4. Now we all know that how we will check for 1. How we will check? We will check that the number itself is perfect square or not. Now how we will check the perfect square? We will make a function perfect square, and in which we will find the square root of this and we will multiply it by the square root. Means what we will do, we will find out the square root of n. So initially n is equals to 9, so we will find its square root. So its square root is 3. We'll multiply it by 3 and we'll check that this is equals to n or not. So in this case it is equals to n, so we will return 1. Now what we will do, we will check for second condition that number can be represented as n minus some square. Means any number whose subtraction comes to be this. Means if I multiply this I into I, the given value, this value should be square of something. Means if I is equals to 1, suppose in this case what it is, we have n equals to 10 and I equals to 1, and this I is also equals to 1. So 1 plus 1 multiply 1, 1. 1 minus, sorry, 10 minus 1 is equals to 9. So 9 is a perfect square of 3. So we can represent 10 by 2's number, or by 2's square, or by 2 number of perfect square. So we will return here 2. Now we will try to check it for 15. Now first of all we will check the number is a perfect square or not. Now easily we can identify that this is not a square. Now after that we will check for second one, which is this one, that 15 minus 1, so 14 is not a square. Then 4, it is also not a square because it will be becoming 11. Now after that 9, so 9 minus 15, it will be 6, so 6 is also not a square. Now after that 16, now 16 is greater than 15, so we will not check it for that. Now the main condition, or the epic observation, or you can say the soul of this question is that if modulus 7, or sorry, modulus 8 is equals to 7, then it will use 4 perfect square numbers to make that number. So if this condition becomes true, then we will return 4, else we will return 3. Now why this condition is become true, or why this condition is true, you can check on Lagrange's 4 square theorem, which is on Wikipedia. I'll give you that link. Now simply if we want to verify, we can verify it. So suppose for 15 this remainder is 7, so for 15 we require 4 numbers only. It will be 3 into 3 plus 2 into 2 plus 1. So it will be like this. So it will be becoming 9 plus 4, 13 plus 14 plus 15. So we will require this theorem only. Now after that we will check for 7 also. Now before only we have checked for 7. Now we will try to find out it for some more values. It will be, suppose it will be 28. Now for 28% 8, it is not equals to 7. If you will check it, it will be coming 4. So it will be coming 4. Now for making 28 also we will require 4 numbers only. Now how this condition becomes false, this is also explained on Wikipedia. You can check that thing. Now I'll explain you in brief that this 28 can be represented as 2 into 7. Now what is the problem? that this 7 only require these 4 numbers to be executed. This 7 require 4 numbers to be written, but this 4 will require only 1 number. So combinedly, if we check, it is using 5 numbers. But if you can check it for 7, what is there? 2 into 2 plus 1 plus 1 plus 1. So what we can replace? We can replace it with 2, and we can replace it with 2 into 2. Sorry, we can replace it with 4 into 4. So this will also work for 28. Now what is the problem? That for the number whose remainder is 7, this condition is not becoming true, means this condition becomes not true at that condition. So what we will do, initially we will divide this number, means suppose number is 28, then we will divide it by 4 if its remainder is 4. So initially at the starting point only we will do this thing, so that our answer becomes true. And now we have checked for 1, we have checked for 2, we have checked for 4, now which is remaining 3. So if it does not become true for 1 as well as for 2 as well as for 4, so we will return 3. Now we'll look at my code and we will submit it. So this is the solution for the second approach. First of all, here this function checks that a number is square or not. So first of all, in this first line we are trying to find out this line, we are trying to find out the square root. Now after that we are checking that the square is equals to n or not. If this condition becomes true, then we will return true, else false. Now this is our checking part, that this is true or not, this square root is true or not. Now first of all, what we will check? We will check that if the remainder is 4 or not. If the remainder is 4, then we will divide it by 4. Now after that, this n%8 is equals to 7. Now for that we will return 4, the second condition. Now the third condition, we will check that if n can be represented by its square or not. So it can be represented, and then we will return 1. Now the third condition, which is n minus I square, here I will iterate from 1 to from I equals to 1 to n, or at every condition it will check that I square is less than n or not. If it is less than n, then this condition becomes or this loop will be terminated. After that, if this 2 is also not returned, then we will return this 3. So this is a very simple code, but a tricky part is that we have to identify this condition, that 8% 4 equals to 7 condition becomes false when n equals to 4 comes. So we will remove this error from this code and then we will submit it. Now if I submit the code, I got accepted, and if I check more details, it is faster than 100% of the submissions, means it is the fastest solution. Now if I check the memory usage, it is bit high, or it is not that much high because it is approximately 90%. So we have achieved that what we want. Now at runtime also we are faster than everybody. So this is a good question, but the tricky part is to identify that %4 error, and if you can identify that, then you can easily submit this solution. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.